All right, today's video we're going to be talking about sequences and series, and just want to talk about some kinds of problems that IB has asked in the past that I've seen in my own experience are common style for them. So the first one is asking us to find the sum of all multiples of 3 between 100 and 500. If you tried to do this the hard way, you'd have to first list all the multiples of 3 and then add them all up, and so obviously we have to be a little bit more elegant in our approach here. Important thing to know about multiples is this. If you were to list any set of multiples, you are making an arithmetic progression or arithmetic sequence. Multiples of 5 are 5, 10, 15, 20, 25, 30. Basically, we just keep adding 5 and we get the next multiple. So multiples of 3 are no different. We just keep adding 3 and we'll get the next multiple. So first trick is to recognize that multiples make arithmetic sequences. The common difference is the multiples. So if we have multiples of 3, then the common difference is going to be 3 because that's what we keep adding. So now we have to find all of the multiples of 3 between 100 and 500. And so I first find the very first multiple of 3 that I can think of that's bigger than 100. Add the digits together. It's divisible by 3, so I know it's right. So 102 is the first multiple of 3 after 100. So that means u sub 1 is 102. That's the first term of my arithmetic sequence. Then I find the last multiple of 3 until I get to 500, and that's 498. Problem is, I don't know how many multiples exactly are there between 102 and 498. So what I can do is use my general form of arithmetic sequences to say that the u sub nth term, which can be calculated by the first term, 102, plus the common difference 3, times n minus 1, and I do know that the nth term in my specific sequence is going to be 498. So I set this expression equal to 498, do some simple algebra, and find that n equals 133. That is to say, there are 133 multiples of 3 between 100 and 500. Now that we know how many terms there are, we're going to use our summation formula. This is 133 terms. If you add up all 133 of them, you take 133 over 2, take the first term, add it to the last term, and multiply. So doing all the simple work there, we end up with the number 39,900. Yeah. Okay, so that should be pretty straightforward enough, but I wanted to, let's see. Yeah, we'll move on to the next problem. For this one, we are given summation notation, and essentially we have this rational function which is taken to the nth power, and it is n that starts at 1 and goes up to infinity. Now, what you should notice is x is not part of my summation. X is just an unknown value. If I choose x to be 7, then this would be 14 over 15. If I choose 14 over 8. I'm not so good with math. If I choose x to be 0, this would be 0 over 1 or just 0, so that's not very interesting. But whatever you choose x to be, it's going to make this a fixed number, and then we're going to take that fixed number to successive powers and then add them all up. So that's just trying to understand what this notation is telling us. Now what it's saying is, look, sometimes if you add up all of these numbers, you're going to get infinity. It's just going to keep on going, getting bigger and bigger. But sometimes, if we choose the right numbers for x, we will be able to add up infinity terms and get a finite sum. So that should be enough to recognize this stuff right here is the R value, the common ratio of a geometric progression. And so all we need for this to work is to have R be less than 1. So the way I show that is I want the R value. Now, keep in mind that x can be positive or negative because x is any real number. We make the absolute value of 2x over x plus 1 less than 1, which is some fundamental algebra skills that you got to have. I broke it all down and found that if x is any number between negative 1/3 and 1, then the common ratio in my geometric progression will be will be less than 1. You can check it by putting in a number like 0. 0 is less than 1. You can put a number like 1/2, which would be 1 over 3/2, which is 2/3. 2/3 is less than 1. So this is valid. So any number for x between negative 1/3 and 1 means you have a convergent series that can be added up to infinity. Now that we know that, we need to actually calculate. And so the first thing I need to do is I need to know the first term in the series. That's easy enough. That's when n equals 1. So we have 2x over x plus 1 to the 1 power. That's our first term. The second, or sorry, that's our first term. The common ratio is 2x over x plus 1, which is the same as the first term, because to get from the first term to the second term, you just multiply by 2x over x plus 1. That's how I squared it. And multiply by 2x over x plus 1 again, that's why I cubed it. So the common ratio is also 2x over x plus 1. So in my formula, the sum to infinity should be 2x over x plus 1 over 1 minus 2x over x plus 1, according to that formula. Simplify, and you get the expression, 2x over 1 minus x. So if I let x be any number between negative 1/3 and 1, and I added up all the terms in that particular series, I would get the number 2x over 1 minus x as the sum of all of those terms. So that's pretty significant, powerful work we just did right there. So I hope you found this helpful, yeah, thanks for listening.